Okay, by now you have learned how to make basic two-dimensional features. These are sketches and whatnot that, although technically they are three-dimensional because they've been extruded, they still really only exist on a two-dimensional plane. And if you were to take a cross-section, it would be the same. And if you were to take a cross-section that is on a plane parallel to this, it would be the same at any point. Now, however, today we're going to learn about more three-dimensional features. These are features that either A, do in fact require three dimensions to function, or B, features that can only exist on an already extruded part. I count cut extrudes out of this because cut extrudes just basically use sketches, and you can build cut extrudes into the sketch of an extrude by putting contour inside of another contour. However, you don't want contours to intersect like a Venn diagram. That creates selected contours, which is not something fun. Now, the most basic of these, and the one that requires absolutely no sketches for itself to run, of course, it requires a part that has to have been sketched, but it doesn't run off of any sketches or sketch parts or anything, is the fillet. The fillet is effectively what a fillet means is that we round the corner of a part. We use this most of the time. Whenever we have a sharp edge, we will typically use a fillet. We will definitely and have to use a fillet if we have an interior sharp edge. This is because our machines cut using a circular bit, which can't make itself infinitesimally small and cut a 90-degree angle. Like, even a laser cutter can't do that. That laser has a really small radius. No, like, conventional machine can do that. So that's why we have fillets. This part didn't have any interior angles, but it did have exterior angles. So those have been filleted to a radius of 0.125. Why is it that radius, and why can it not be any radius smaller than that? Because our bits have a 0.125 radius. They are quarter-inch bits. Their diameter is 0.25, and their radius is half that, 0.125. Then you're asking, hey, what about these 196 holes? These are made with a different bit. That is our 196 bit. For complicated reasons that I will get into in a CAM lesson, because that's when it really becomes relevant, you cannot use the 196 use the 196 hole to make anything. It's 196 tool to make anything other than a 196 hole. It's just the way it works. Now, beyond fillets are more interesting features. So, the most essential component of our robot is something called tubing. So whenever you make tubing, you're going to start out like this. You're going to hit extrude boss base. You're going to select the top plane. You're going to make a rectangle that is 1 inch by 2 inch. Please try to use this orientation. It just looks nicer. Now, you're going to exit the sketch. It'll bring you now to the extrude menu. Now, typically I just put in the length and then I click the check mark. But now we're doing something else. We're going to thin feature. We want this on. We're going to invert the direction that thin feature is going inwards. And I'm going to set this, the thickness of the thin feature, as 0.125. Because this is thick wall tubing. Alternatively, we can have thin wall tubing, which is 090. What do you know? The dimensions kind of match up with our two most common pieces of sheet metal. Of course, there isn't really thick wall tubing with 0.25 inch thick walls. That would be heavy and kind of defeat the purpose of us using tubing, which is meant to be at least decently lightweight. Now, I'm going to make a 10-inch tube. Oh, another thing. The thin feature. You cannot hit the check mark and extrude something and go back and thin feature it. It doesn't work that way. Once you've made that extrusion, if you didn't make it in thin feature, it's not going to be thin feature, and you'll have to delete the extrusion and re-extrude from the sketch. Alternatively, you can do some bad CAD practices, like making a cut extrude from the top back down, or making a normal extrude but putting two rectangles nested within each other. We don't want to do either of those. They take more time, and also I would believe they increase file size, and also it's easier to do it this way. Now, we hit that, and this, it's a hollow, tube. Now, thing is, you'll never see anything like this on a robot. What's the first thing you'll see to this? Well, along this edge first, so we're going to hit C for center line. We're going to hit A for arc, S for smart dimension. You want to guess the diameter? That's right, it's 0.196. Now, we're going to hit S again to the bottom edge and 0.5. Now, there's something I learned very early in CAD. It's never ever do something manually if there's a tool that will do it for you all at once. Now, I was about to make the same mistake you would probably make in this situation, which is make another circle, make it equal 196, make it 0.5 or 0.1 from this, depending on which model of tubing we're using. However, when I did that, all of my work got deleted by Jack, our CAD lead, and he told me there is a simpler way to do this and a quicker way. And as I mentioned in the first video, efficiency is key. Here's one of the most useful buttons to you. Linear sketch pattern. You select the entity that you want to pattern. In this instance, we have to make it 90 degrees. It's a unit circle, so 90 degrees is up, 0 is to the right, 180 is to the left, and 270 is down. We're going to make the spacing 0.5. We used to make the spacing 1 inch, but something changed in our tubing convention. We used pre-made tubing instead of tubing that we'd make ourselves, and that was the hole spacing, half inch. Now, if it was 1 inch, the amount of holes would be easy. It would be 10, because it's 10 inch. However, it's 0.5 inch, so it's actually 10 plus 10 minus 1. So there's 19 holes in this piece of tube along that side. You notice linear sketch pattern? Now, although I did do that, I do, however, have to I now have to define the distance of the first one. This is the easiest kind of sketch pattern. Sometimes when you're doing things with hexagons, when you're lightning pattern, which we will get into later, they don't like to do that properly in the linear sketch pattern. They don't, especially like anything actually with triangles, doesn't like to define very well in a linear sketch pattern. You will be taught or will figure out on your own a workaround. If you can find a workaround that's more effective than what I've had to do, by any means, please use it. That's amazing. Anyway, so first things first. Now we're going to exit this sketch and cut extrudes. Now, blind we never use. Now you remember last time I talked about up to next, but that's only going to cut through this wall of the tube. We're going to choose not through all, and definitely not through all both. Up to vertex, if I select that edge, might work. However, we're going to use up to surface. I'm going to select this, and you notice this is going to cut straight through that tube. That yellow is what is the cut path. Actually, that's exactly what our machine Dumbo, which we use to make all our tubing, does. It will cut through this. The person operating will speed it up before it reaches this, at which point they'll slow it back down, and it'll go through. Now, actually, material, very important. 6061 T6 SS. Now, although this has now been cut, this side also has to be cut. What I'm going to be making, actually, is just your basic, covered in holes, piece of tubing. This is the most common type you'll see. Now, let's see. Do that. Do a very similar thing as to what I did earlier with, actually, what I'm going to do is I'm actually going to a center line, but rather go from line to line, make this 0.5. Let's put a hole here, .196, and let's make that 0.5 from the edge. Now we're going to take this, we're going to linear sketch pattern it all up, so the degrees as 90. Actually, cancel that. I'm going to select both of these. Linear sketch pattern, degrees, 0, 3 instances, half-inch spacing. Remember, the instances includes the original as well. Hit OK. Set this spacing as 0.5. Select all 3 of these bad boys. Linear sketch pattern, 0.5 inch spacing, 19 instances, 90 degrees. Beautiful, right? Hit the check mark. Exit sketch, up to next, no, sorry, up to surface. Select the surface it's going up to, hit the check mark, and bam, you have a beautiful, shiny, new piece of tubing. Now, because I'm currently offline, I can't save it to the drive. However, I will save it to documents. This is not something you'd normally do. You would save it to the drive, but at the moment I can't do that. Our naming convention, 2168, dash the year, dash, and this is training, see, training video demo 2. Yes, this is still a demo. We may use this, actually, but actually, you know what? We're probably going to use this because I did 6 takes of it. Anyway, so we may use this, but as of right now, this is still a demo. It still has to be approved, and then... Yeah, so right now, this is a demo. Anyway, I'm going to hit save. Typically, I would have been putting that in my training folder. However, I am offline at the moment and cannot access the drive. So this is your beautiful new piece of tubing. How do you like this? Now, we would shove this in an assembly. But for today's lesson, this is basic three-dimensional things without getting into sheet metal, which is a whole other can of worms. Yeah, I don't like this tab. If you couldn't tell, I really don't like that tab. But yeah. Anyway, that is it for this lesson. That is just basic three-dimensional things. You've gotten an introduction into tubing. You've learned about fillets. You've learned why we need to have them, especially on interior angles. Not these, because... Actually, I'm not even sure how they make tubing, so... Yeah, I don't know why maybe it's lazy. I don't know how they make tubing. So, actually, I don't know why the interior edges of tubing aren't rounded. Maybe they are, like, rounded very slightly. But I haven't noticed that. I've just made myself out of an existential crisis. But that's not important. What's important is you now know a few really nice things. Linear sketch pattern, up to surface, how that works, thin feature, and... Yeah, oh, that reminded me. Always, always remember to name the items of your sketch tree. So this is thick wall tubing. Thick wall, 2x1 tubing. Or rather, 2x1 thick wall tubing. And then this one is 0.196 holes. Short face. And 0.196 holes. Long face. Always, always remember to name your feature tree items. Anyway, that's it for this lesson. I will probably start recording the next one immediately. But yeah, for now, that's it.